Good morning, I am Abhisatvika from CSC A section. Today my topic is Principle and Applications of NMR and IR spectroscopy. First, introduction of spectroscopy. Spectroscopy involves studying how matter interacts with electromagnetic radiation. It is used to determine structure and bonding and composition of molecules. It is two methods, NMR and IR spectroscopy. Electromagnetic spectrum overview. It is different types of radiations like UV, visible, IR and radio frequency. NMR spectroscopy uses radio frequency region. IR spectroscopy uses infrared region. What is NMR spectroscopy? NMR spectroscopy is a nuclear magnetic resonance based on magnetic properties of nuclei such as hydrogen and carbon. It provides detailed information on molecular structure. When principles of NMR spectroscopy. When nuclei are placed in a magnetic field, they absorb specific RF energy. Resonance condition V equal to YB0 by 2 pi. It absorbs frequency depends on the magnetic environment of the nucleus. NMR chemical shift. The position of NMR signals is called the chemical shift. It is measured in parts per million, like ppm. It indicates the electronic environment of hydrogen and carbon atoms. Spin-spin coupling. It is interactions between neighboring nuclei and spins. Splits NMR signals into multipliers. It provides information about number of adjacent protons. NMR instrumentation. Instrumentation means components. Components like magnetic system, RF transmitter and receiver. Sample probe, detector and computer. Output. NMR spectrum shows chemical shifts and intensities. Applications of NMR spectroscopy. Identification of organic compounds. Structural and conformational analysis. It is used in medical imaging like MRI scans and CT scans. Studying biomolecules like proteins and nucleic acids. What are IR spectroscopy? IR spectroscopy studies absorption of infrared light by molecules. It causes vibration of bonds like stretching and bending. Each bond type observes at characteristic frequencies. Principle of IR spectroscopy. Molecules like observe IR radiation only if vibration causes a change in dipole moment. Frequency of absorption corresponds to bond vibration frequency. IR regions and spectrum. Near IR region is 14,000 to 4,000 cm inverse. Mid IR range is 4,000 to 400 cm inverse. Far IR range is 400 to 10 cm inverse. IR spectrum shows transmittance versus wave number. IR instrumentation. Main components: IR source, sample cell, monochromator, detector, recorder or computer. Applications of IR spectroscopy. Identification of functional groups, detection of impurities, analysis of organic and inorganic compounds. It is used in pharmaceuticals, polymers and environmental monitoring. Conclusion. NMR spectroscopy reveals atomic level structural information. IR identifies functional groups and bound vibrations. Together, they provide a complete understanding of molecular structure. Thank you. Advantages of NMR spectroscopy. Only fluids are visible of NMR technology to porosity measurement in independent of the lithology. It procedable zones with a high percentage of clay bound water can be identified. A better measurement of permeability is possible than traditional paths. In situ measurement of oil viscosity. It is differentiation of oil and gaseous zones. Disadvantages of NMR spectroscopy. It is good for more accurate determination of the strength, but not for the availability of high molecular weight. The resolving power of NMR is less than some other type of experiments. Example: X-ray crystallography. Since the information got from the same material is much more complex. Unfortunately, we are just able to determine the degree of probability of being of protein segment in the given conformation. The cost of the experimental implementation is increasing with higher strength and complexity of determination. Thank you.